Clinical trials in the U.S., Elon Musk's Neurolink has secured Health Canada's approval to kick off its first international study. Recruitment for the trial has now started in Canada. Dr. Andres Lozano is the neurosurgeon leading the trials in this country, and he joins me now. Dr. Lozano, thank you so much for joining me today. Walk me through, first of all, how all of this works. I mean, this is pretty incredible, this implant that's being put in the brain.
Well, we are interested in helping patients who are paralyzed as a consequence of a spinal cord injury or ALS, amyotrophic lateral sclerosis. So these are people that cannot move their arms or legs.
Right.
But yet their brain works perfectly well, and the areas of the brain to control movements are working perfectly well. So because they can't use their muscles because of the spinal cord injury, what we're going to do is we're going to take the signals from the brain and use those signals to move a cursor. So we're going to bypass the injury and decode the signals that they are generating, and we'll be able to let them use a cursor to move a cursor on the screen, to click, to play a video game, to activate a device, to move a robot, etc. So it's really quite exciting to be able to harness these signals that are not being used by these patients because of their injury, and to then give them a voice.
Are there risks involved with all of this? I mean, you are putting a foreign item into one's body, let alone into the brain.
So the types of patients that we're seeing are extremely disabled. They are paralyzed. Some of them can only move their eyes and mouth. So they have no movement in their shoulders or below. So they're a bit disabled. And then the surgery itself, though, is relatively straightforward and simple in the scheme of things. It is a neurosurgical procedure. We do have to open the skull, and we're implanting 1,000 electrode contacts in the brain.
Wow.
And this is done with a robot, a very sophisticated robot that acts somewhat like a sewing machine and is extremely precise and accurate, and we think safe. So the technology has advanced to the point where we think that we can implant 1,000 contacts in the brain, and we can listen to the activity of the neurons in the brain, and then we can take the signals of these neurons and use it for something useful.
Because you're dealing with signals, Bluetooth, Wi-Fi, and whatnot that's involved in all this, are there some concerns about something being able to tap into this technology or hack into it?
So indeed, these are signals that are being generated, and they have to be transmitted from the brain through a Bluetooth signal to a receiving device. So in theory, those signals could be hijacked or could be hacked. And someone else could use those signals for something else. And then in the future, right now we're talking about reading the activity of the brain, but in the future we're also going to be able to write into the brain. We're also going to be inputting information into the brain. So for example, someone who's blind, we might be able to use a video camera and use the signals from the video camera directly to input those into the brain, bypassing the injury and the disease in the eyes, for example. So someone who's blind, we might be able to use those signals and put them into the brain. So there's a possibility, it's really going to be a two-way street, a two-way communication between machines and the brain. So we call it a brain-machine interface. So as there is a transfer of information either in or out of the brain, then there's a possibility for those signals to be hacked, if you like. So we have to be extra careful to make sure that the proper safety measures are in place.
You were just talking about, being able to, eventually at some point, helping someone to be able to see, maybe even, providing them with more independence. Overall, then, what are you hoping the end game could be with this type of technology, or is it almost endless?
Our end game is really to restore function.
Okay.
So if you have a disability, if you cannot move, if you cannot see, if you cannot speak, if you cannot hear, we think that we might be able to talk to the brain directly and let the brain do things that it would not otherwise be able to do. And we'll also be able to record from the brain and use those signals to use those signals for good use. So really what we're establishing is a communication in someone who's locked in, someone who's not able to communicate with the outside world, someone who may not be able to receive signals or use their brain to activate activities. What we're trying to do is to restore their function. So we think it has widespread implications. And right now we're talking about doing the third human being in the world. And the purpose really is to determine whether this is safe.
And would that be here in Canada?
And that'll be here, and whether it's safe and whether it could be effective and whether it is justified to scale this up so that we can go from from the initial 6 patients that we've been given permission to treat to a wider scale. Can we make this available to people from all over the world that are suffering from these disorders and disabilities?
And is it 6 patients here in Canada?
Yes.
You'll be focusing on? Before I let you go, I mean, this is incredible work. I guess the drive behind it. Talk to me a little bit about that, as it's not just you. I mean, as you mentioned, you in our conversations, there are hundreds of researchers that are involved in putting all of this together.
There's a huge team of engineers of decoding the signals, of making the electrodes, the robots. So there's a huge team. This is a huge, it takes a village to do this. And really the excitement is that we've now reached the technological advances to be able to do this, we think, in a safe and effective way. And we think it's going to open a possibility, and I think we have the potential of really helping many people that are disabled because of a neurologic disorder or an injury. So I think it's a very exciting project, and we're looking forward to being able to play an important part in it.
Essentially giving people back their lives, Doctor.
We hope so. Restoring their function.
Indeed. Thank you so much for this, Dr. Lozano. Appreciate it.
Thank you very much.
You're welcome.